continue our two-part podcast as we discuss new research conducted by Dave and Cameron Walker that goes past industry opinions and examines actual water tank projects and product data to determine which coating systems provide the longest service life and lowest life cycle cost. Well, you guys had mentioned that you've worked on this paper for over a year and a half. Tell us a little bit about the process of writing it and some of the challenges that you encountered.
Yeah, so to start off with, we really took a wide glancing approach at what's out there in the industry. And we found a number of opinion papers that have been published out there. But when we looked at raw data that helps predict the service life of coating systems, there's really not a lot out there. There's the individual case history and studies that individuals have completed, but there's nothing that's been completed on a large scale that's been over grasping on the water tank industry. And so we went and looked at the smaller aspects of data that's available out there and the case histories that we've completed and collected over the last 15 years of working in the industry, and used that as the basis of forming the process of coming up with predicted service life.
And actually collecting that information over a long period of time was key, because trying to survey people, again, you're getting the bias of their experience. So if we were to survey 30 people and ask them for specific tanks, they're only going to remember those tanks that are unique in their memory, and therefore it introduces bias into it. And the difficulty of collecting that data is true, because even during our research, we ran across an attempt in the 1980s of somebody else trying to collect that data for what was going on in the 80s in water towers. And, you know, they did phone interviews, they did written surveys out. What tanks have you got? What technology do you have in it or on it? How long has it been in service? And in the summary of their report from the 1980s was, it was frustrating. They got a 5% response rate. And so having those hard numbers was key to set the base of the data for us to then start filling in the blanks.
And we were really beneficial with Dave working in the industry for a number of years now, and being able to have those case histories of climbing tanks themselves and assessing them, and knowing when they were installed through resources with the owners, as well as being there when those tanks are being replaced and being able to identify the end of life for those coating systems.
And that was one aspect that, you know, when we surveyed the results that we had, we threw out results if we didn't know the exact time of when that coating was applied. Being a guesstimate, early 90s, mid 90s wasn't exact enough. So we not only needed to know when end of life was, what the technology was, how thick it was, but we needed to know exactly when it was installed, because a guesstimate that could vary 4 years when we're trying to estimate an 18 or a 20-year lifespan can have significant percentage influence on what that data is.
So if you had, in this paper, you were able to utilize 180 plus tanks, you must have thrown out a lot of tanks that had incomplete data.
Yes. Unfortunately. And we excluded. So in the tanks that we looked at were tanks that were still in service, that hadn't reached end of life. And so therefore they were set aside as well. We had results that were technologies on the exterior of tanks that technology is not used anymore, or it has changed dramatically. So alkyd systems, whereby the technology was lead-based alkyd, which doesn't reflect the current alkyd technology that in the D102 standard. So those results were set aside as well and not used for predictive purposes.
And then we had a number of case histories with tanks as well that were overcoat systems, where you have some acrylic paint applied over top of, say, a polyurethane finish on the exterior. And while that doesn't give a true representation of either system and the performance levels, so those had to be excluded as well.
So you took a look at some of the previous industry information that others reference. You found 180 plus usable tanks that you could include in the study, and took a lot of performance data, accelerated data as well, to round that out. What did you learn from the research that challenged some of your own opinions that you developed over the years?
I think the biggest one comes down to the use of zinc-rich primers. And so it's commonly agreed in the industry, especially in those opinion papers that we looked at, that the use of zinc-rich primers underneath all those systems extends that service life through galvanic protection of the steel surface. And our opinion originally was that this primarily came into effect near the end of life of that coating system, when the liner starts to break down and you get failure points, and that's when the zinc allows galvanic protection. But through studies that we had conducted ourselves, as well as resources out in the industry, we noticed that the zinc-rich primer itself actually has beneficial properties right out of the gate when that coating system goes into service, and that coating lining slowly absorbs that water, and the water passes to that steel. That zinc reduces that formation of corrosion onto that steel underneath the lining system itself.
So yeah, for many years, people would, when we talked about zinc-rich primers, I always spoke from my opinion that it only comes into effect at end of life. And to actually delve into the data, the testing, the performance criteria, and to see all these other variables start to kick in long before end of life scenarios, and to see the performance difference by that zinc being there was eye-opening to me. So it changed an individual's opinion based on the research that we were doing.
And so that falls into the performance testing and lab testing aspect of what we looked at. But in terms of what kind of opened our eyes in terms of the case histories is the true variability of how long these coating systems can last. We had some coating systems that were marked as a case history that lasted only 4 years, while that same technology and coating system can last up to 30 years. So it really speaks to the influence of all the properties and decision-making markers that go into designing a coating system for a specific asset. And that just because you pick one certain coating technology doesn't mean that you're going to get a fixed service life for that coating.
And one of the other biggest things that as we dove into the data, and whether it was somebody else's data, a published industry report, or whether it was testing that we ran ourselves on the variety of coating systems, is to see the variety and the influence, as Cameron describes, in the end results between technologies that are sold as being equal in the marketplace. That as a decision maker, you might not know any better A from B from C, but it was amazing to us to see the variability in the capabilities in those performance criteria and those testing that we saw between individual formulas.
Well, I think that goes back to the importance when you're taking a look at a manufacturer's products and the coating system, D102 coating system that you're considering. It's important to make sure they've got case histories that are proving that this product and this system is appropriate for that environment. It's going to last as long as possible, but also taking a look at the performance data. And because all these products, even though they may generically read the same, there are some distinct differences in formulation and approach in formulating that can have severe impacts on the ultimate performance of the products and the systems themselves. And that really goes to the desire of the owner, especially, and of course, the responsibility of the engineer to specify systems with products that are going to last as long as possible. And I think a lot of people, of course, they're worried about the big budget number, the initial application, the price per gallon, but you guys really tried to keep the true life cycle cost in mind as you were going through this. Tell us about the focus on life cycle cost, and also what went into that. How did you help calculate that?
Yeah, so for lifecycle costing, it's very handy because it gives you the perspective of what am I going to see long term. Everyone gets stuck on the upfront cost, the capital cost to invest into that coating system, but what is it going to cost 50, 60 years down the road when you're replacing these coding systems multiple times? And so for lifecycle costing, we take into consideration the overall cost of the contract, like the material costs, the labor costs, the access costs, as well as the removal costs for those coding systems, because it's going to cost money to remove them when you need to replace them. But the biggest thing that the paper aimed to do was come up with that predicted life cycle so that you could conduct life cycle costing with an accurate estimate.
And when we go through the life cycle costing in detail in the paper, there are costs that we chose to exclude because they were hard to formulate. Engineering costs, because they could vary depending on the scope of work. Is it a new tank build? Is it a repaint? Are there safety upgrades? Are there tank modifications? As well as third-party inspection, because that varies so much whether it's full-time or part-time or the scope of the work itself. The secret to those costs being excluded, though, is they should be included, because we advocate that life cycle costing and life cycle cost analysis should be done unique to every asset that you're looking at. And therefore, you're able to quantify those costs and bring them in, and they actually amplify the effect of the meaning of life cycle being important, because that adds more costs. So you want to have the longest life that you can so that you don't incur those costs more frequently. The longer that you can set those costs off, the better off you are, especially when the cost of the coding is such a small percentage of the overall project itself. All these other costs, the majority of the costs, you don't want to incur them more frequently.
Well, I think everyone's aim is to get the longest life out of these coding systems that they can. But I think your paper, which is excellent work, really delves into the details of guiding that decision-making process to make sure that they put everything in line to help ensure that they do get that longest life cycle and therefore the best life cycle cost and value. It really is a great paper. There was a lot of work that went into it. Tell us how is this paper being utilized? How is it being presented? Because there's a lot of data there. It's not one that you can just quickly browse and understand. There really is an incredible amount of detail. Tell us a little bit about how the paper is being presented, and how, if we've got listeners that are interested, how can they get a hold of the paper?
Yeah, so with the paper, I think it came out to 32 pages long, and there's a lot of information that's in there and a lot of detail that goes into explaining the reasoning behind things, and it can be a lot to absorb. And so what we've been doing over the last couple of weeks is going out to engineers and owners, as well as other experts in the industry, and kind of giving them a quick 1 hour run through of the paper and the overall arching findings. And then they can then better understand and go into the weeds and details into that paper and get the true full picture. But giving that high level really helps the individual absorb that information the best that they can.
And as Cameron describes, the presenting it on a higher level, trying to show the methodology and the summary of the results, it's been very well received because it's factual based, it's data based, it's a methodology that people can follow and have faith in their decision making process. And in the industry, when so much of the industry has historically been opinion-based decision-making, experiences going into the formation of the opinion to make decisions, it's nice to have data to help have faith in the methodology and the end result that we're getting to make that decision.
And at the end of the day, the true goal of the paper is to be able to have it as a tool for individuals to use to make decision-making, and to have a resource behind them instead of just opinion of, oh, this one person said I should do this. And that it's a resource that they can fall back on for understanding why they might be making that decision.
And the paper itself is designed to be a living document, that it's not set in stone and done now, that we continue to this day to do more testing, to add more data to that, to fill in more structure of the overlying decision-making model to have faith in that. We continue to collect more case histories to add into that, to extend beyond, because the more that we can add to that, the less influence of outlier cases or bias that's in the data, we can get rid of that or minimize it in the results.
And like how Dave had mentioned before, as the industry changes and grows with regulations changing, we're sitting here in the coatings industry looking at changes with NSF 61 and 600 and how that's going to influence the decision making and coatings that are available for the interior of water tanks. And that's probably going to drive innovation and change in the technologies that are available. And so we see that this paper is probably going to have to be updated to reflect those new technologies as they come into the marketplaces.
And we continue to go out to industry associations where there's an audience for this information and submit the paper and the presentation. And that's the easiest way for people to get a copy of the paper, is to have that summary presentation done for them so that they understand the methodology. And therefore, as Cameron describes, when they get the paper and read it, it's much more flowing, and the groundwork is set for them to be able to make their way through the 32 pages.
Well, it's a great paper, a great resource. You put a tremendous amount of work into it, and it sounds like you'll have work in the future as well as you take a look at some of those tanks that are in service, new technologies are developed, and you'll continually add to the paper, which is fantastic. Well, gentlemen, thank you very much for your time. It was a great session with you, and we really do appreciate the amount of effort and work that went into this paper. I think it's going to be a valuable resource for engineers and owners alike.
Thank you very much for your time and your questions. And yes, we have faith that it is a valuable tool, and we look forward to people making their way through it and drawing conclusions from it.
Selecting a coating system for a water tank, engineers and asset owners often rely on personal experience and professional recommendations. But a recent investigation of real-world case studies and a detailed examination of coating performance data resulted in valuable insights that help direct selection of the best coating system with the longest service life and lowest life cycle cost. To schedule a presentation of this research, visit tnemic.com/water tank service life.